Dear viewers, I welcome you to the class of convection. So, before entering the actual content of convection, we will revise the basic concepts which was there in module 1. So, fine. What was that convection? If you remember, we had three different modes of heat transfer: conduction, convection, and radiation. And convection was that mode of heat transfer which involved fluid as a medium. Fine. I repeat, convection was that mode of heat transfer which involved fluid as a medium. So now here as an example you can consider any system which had a heat transfer between a solid and liquid, or solid and gas, or liquid with gas, or I can also say liquid with liquid, or gas with gas. If any of these systems are involved in heat transfer process, all those things can be given as an example for convection. Fine. So in general this can be written like any heat transfer between a solid and fluid, or between fluid and fluid. Any heat transfer between these systems can be called as mode of convection. Okay, there has to be a current of the heat, current of the particles, current of an atoms. Fine. If there is a solid like any hot plate, the atmospheric air, which is an example for fluid, it picks the heat from that hot metal, right? So that can be given as an example for convection, because there is a current of air. That means air will be moving. This mechanism will come across again. We'll come about the detailed explanation for this mechanism further. Fine. So convection is broadly classified into two different categories, like natural convection and forced convection. Remember, natural convection is also called as free convection. Free convection or natural convection. So now there was a law which was governing convection, and the law was Newton's law of cooling. It was Newton's law of cooling. The statement of that Newton's law of cooling is rate of heat transfer, represented by capital Q, is proportional to the surface area, that means the area whichever is exposed for that convection, surface area, and the temperature difference between the surface and the surrounding. Okay, so now this proportionality sign will be removed by adding a proportionality constant called as H. So this is the rate of heat transfer equation to find out rate of heat transfer. Now let us have a unit for this H. We'll take the expression over here. For getting that H, I need to have arrangement of that equation in this manner. So Q equals H into A into Ts minus T into same equation I have written for H. So now rate of heat transfer is watts, area in terms of meter square, temperature difference in terms of Kelvin. So I will get H as in terms of watt per meter square Kelvin. This is the unit for H. And always remember, this H is a heat transfer coefficient. never say that H has property of any material which has been involved, property of system. Never say this. For example, if we take this same example again, a hot metal left open in an atmosphere, air comes in contact. So this H over here, the H will never speak about the air or a solid metal. It will never speak about the properties. So this H is not a property for a system. Okay, it is a coefficient for the process. So H is defined for the process, not for the system. Make a note of it. Never say that H is a property. It is not. Okay, so now coming to the heat transfer mechanism, we have two different heat transfers process, that is natural and forced convection. So for natural convection, let this be a surface, a hot surface whose temperature is greater than surrounding temperature, T infinity. So for a moment, let us say this is an adiabatic wall. All these three surfaces, these are adiabatic walls. So this is the only wall which is provided for heat transfer. If it is left in an atmosphere, I'll get a layer of air above it. Fine, I can imagine n number of layers. Now the layer which is in contact with this hot surface, it will receive the amount of heat. As soon as the heat is received, density of this first layer will be reduced. So by the transfer of a heat to the air, density of air will be reduced, as a result of which it rises up. Okay, as a result of this movement of air, the layer which was above it, okay, that means the second layer over here, if I say this is the first layer, it will rise up, and the second layer, it comes in contact. As soon as one layer of air rises up, next layer, it comes in contact with the hot surface. Again there is a heat transfer. Again the density of air reduces, again it rises up. Fine, there is a motion, continuous motion of this air. So this motion of air is itself called as current of air, or I can say air current. If I imagine water here, I'll get water current. Fine, this current of fluid is necessary, current of this particle is necessary for convection to take place. Okay, so this is the mechanism of natural convection. Now this motion is occurring by means of natural one. No one is forcing it. There is nothing like compulsion. It's a basic phenomenon that as soon as the heat is transferred, density of a system reduces. By that logic, there is a motion of air, right? Current of air, and hence it is natural convection, or it is also called as free convection. In case of forced convection, this motion of air is achieved by means of some external devices, say fans or blowers. So here the concept of velocity comes into picture. Okay, there is no such thing over here because the velocity is almost negligible, so we won't study about it. In case of natural convection, we can directly use these equations provided all other surfaces are adiabatic one. Okay, there is no heat transfer. Then only for one surface is easy way I can use that equation. If there are more surfaces, I just go on adding up the surface area. That is the theoretical manner. Okay, so now coming to the force convection, there is a concept of velocity. So you need to study about this velocity layers. Okay, this comes under boundary phenomenon. So in my next class, I'll be explaining about this concept, boundary concept, what is that velocity layer and all. Okay, in this class, we have just revised the basic things which was there in module number 1. Thank you.